use and display of AIS binary messages are pilots, using their portable pilot units with the pilot plug that's installed on the bridge for this purpose. As such, I think we need to look at pilots as being the early innovators for anything that is supplemental information that's provided in addition to. And a good example would be they have the ability to display information in 4 basic ways. This is a test question, gentlemen and ladies. Alphanumeric, graphical, symbol, or geospatial. I've briefly mentioned some of the meteorological and hydrographic or hydrological. Let's take a quick look at some of the other ones, like we saw, for instance, from having to do with critical information for decision support. In Halifax, Nova Scotia, there are 2 bridges that are the major impediment to safe navigation for ships entering the port. They have about 4 meters of tide and lots of other types of things going on weather-wise that affect the amount of water level. In this case, they have differential GPS mounted on the bridge, real-time information coming continuously every 10 seconds on predicted water levels as well as forecast water levels, and being continually updated as a nowcast. This is provided as an AIS binary broadcast, again using the message 12, is it? Regardless. And displayed on portable pilot units. This is the display that was developed by the pilots, used by the pilots. In this particular case, you can see simple red-green. A red meaning there is less than 1.3 meters clearance for this vessel underneath the bridge. That's an air draft. Anything greater than 1.3 meters, it's green. That's all they need to know. Red, green, safe or unsafe. Now, on the other hand, from a strategic planning point of view, a so-called time series graph showing the changes in the height of the bridge above the water based on temperature or on vehicle loads of the traffic going across the bridge. This is helpful in planning. We saw an excellent example of this by Terry O'Brien earlier this week for the Torres Straits. In this particular case, the box, the rectangle, shows a geographic area of interest for vessels for underkeel clearance. What you see in green there is called a histogram or a bar graph. But it shows not only the location, but the extent or the lack of underkeel clearance for a particular vessel. In the upper right-hand corner, you see other types of information that is best provided as alphanumerics. Things like the route, the station, speed over ground, the current, the swell. It doesn't make a difference whether the bar graph is shown in green, pink, purple, chartreuse. It doesn't make a difference. It does make a difference, though, that you can determine where and when that you would be concerned about, as he says, transit breaches for minimum underkeel clearance. This is what mariners need to know in terms of where it occurs and when it occurs. This is an effective portrayal of information without previously defining exactly what the display or presentation standards are. The other interesting thing about this, when you see the route up in there in terms of locations and times, it also, this in theory could be passed on to the ACTIS in terms of route execution or route planning. One other quick example. The current color scheme used in paper charts was developed hundreds of years ago. On the right-hand side, the deep water is shown as a white color. The shallow water is shown as blue. In reality, from an aerial photograph of exactly the same area, the color scheme is reversed. I don't think there's anyone in this auditorium that could not tell me on the left-hand side which is the deep water and which is the shallow water, regardless of it knowing the exact depths. The IHO, when they developed the colors and symbols specifications for ENCs and ECDIS about 15 years ago, used the paper chart color scheme. On the left, you see safe water shown as white, and increasingly shallow or shoal water shown in darker shades of blue. The reverse color scheme could be used on the right, where deep water is blue and shallow water is lighter blue. And this, in fact, can be used 24 hours a day because blue is not a saturated color like white or black. Interestingly, at this conference, there are several VTS manufacturers that showed their displays. This one I obtained gratefully from Atlas Maritime. Look at the color scheme they use. Shallow water, light, dark water, blue. perhaps this could be considered then the approach for a harmonized e-navigation display for shipborne and shore-based, with the exception maybe of the black in the far right. Interestingly, Marine Data Solutions uses basically the same color scheme, but not necessarily the same exact colors, but the concept is the same. This is one by Selexi Sistemi Integrate. This has the IHO S52 color scheme, but look how elegant the display is, and most importantly, the key information here is the navigation-related information. AIS targets, ARPA targets, the chart information has been minimized on purpose. This is the quiz. For those of you that are mariners, you could probably look at this and say, well, 3D, that's very pretty, but I'm really not going to be able to use that. There are two fundamental things that are wrong with this image. If anybody can tell me on the break what they are, the first person who does gets a beer. The future will be, at present we have more chart-related information being shown and less operational. Then we're going through a transition. The future for e-navigation is, it'll be the chart information is the background, and the operational information will be the key information. These are recommendations for shore-based that have already been spoken. I will not go through these in great detail. A little bit on the shipborne, just to give due credit. Jan Erik Hagen, who is from Norway, is the chair of the IMO e-navigation correspondence group. And talking with him this week, he has already said, yes, we need to review the performance standards for the various equipment systems and services. Now, this is something my small task group started, but it's much better for the shipborne side to be handled by IMO. On the other hand, we will need to do this for the IALA equipment systems and services that are in theory supposed to be harmonized. We need to recommend how to resolve inconsistencies and conflicts. There are not necessarily magic solutions, and we saw some good examples of everything from, let's see, Takamasa-san showed this, what he called ENSS, the Electronic Navigation Support System, which is being tested in Japan. Our colleagues from Poland talked about this. I love the name. What was it? The Polish single window. Potentially could be used in VTS centers, maybe even on board ships. But finally then, to provide recommendations on what systems are currently implemented within the context of where they need to change for e-navigation. Thank you very much.
Thank you, Lee. Well, mariners may be able to tell the difference between a green light and a red light, but certain former mariners and current professors aren't quite so good at it. So I'm sorry to say that we don't have time for questions right now because it's time for the break, but perhaps we can revisit them at the end of the next session. So it's time for a break. Let's give all of our speakers a round of applause. And we'll see you at 15:30. Thank you.